Hi guys, welcome to Deep Diver, and today we will be discussing a struct which is one of the most heavily used construct in Golang. Whenever you will need to write code for real world use cases, you will have to have this struct. Before diving deep into that, let us create the folders and files required for the coding related to a struct. So this is my Golang course. I will create one more folder here, 11 underscore struct, and here I will create a folder structs.go. And inside this, as usual, we'll have package main and our function main as well. Let me add a multi-line comment here as well. Now we are good to go. Until now we have used variables of type integer, string, boolean, float, etc. independently. But when it comes to real world use cases, let us say for an e-commerce website, we need to represent entities like user and product. And these entities can have multiple variables. For example, this user can have name, age, email. Similarly, this product can have name, description of the product, price of the product, etc. That's where struct comes into the picture. To represent these entities, we can use a struct where we can combine all these variables under one name. So now let us define a struct. A struct is a user-defined type which can be used to group multiple variables of different types. So what do we mean by this user-defined type? User-defined type means a custom type created by the programmer. It is not being provided by the Golang programming language itself, but it is the user, in this case me, who will be creating these types. So while defining this struct, I will have the full authority to decide how many variables will be there inside this struct and what type of variables those will be. So this is what we mean here by user defined type. Now let us look into the syntax how we can create and use a struct. The first thing we need to provide is the type keyword. So whenever you have a user defined type, you need to provide the type keyword. Okay, then we need to provide the struct name. Let us say we are creating a struct for user, and then at last the struct keyword. Now we need to add fields here. So this user has name, age and email. Let us add the same fields here. So name, we will add name is of type string, and then we will add age, which will be of type integer, and at last we'll add email, which will also be of type string. If I save this code, you will see this struct getting formatted and it will look much better. So after I saved this code, this has aligned perfectly. Now let us see how we can create a variable for this struct. Let us say we want a variable user1, and we'll give the struct name, and then we need to provide the value of all these fields, name, age and email. Let us say name, we give the value as Ravi, and then age as 50, and at last email, let us give that as ravi@xyz.com. Now let us print this user1, fmt.println user1. Now let us run this code. So I will open my terminal. We'll change it to 11 underscore struct. Okay, now I should be able to run it. Go run structs.go. So you can see here we have the output Ravi, then 50, then the email. So if you notice the order in which we have declared the fields, they have appeared in the same order in the output, right? So now let us move forward. There is one more way by which we can create this variable of struct user. Let us try to do that. I will create a variable user2, and then here what will be the change? Here we will not pass the field name but only the values. So this is for name, then for age, let us say again 54, and then at last email. So suraj@xyz.com. Now let us print this user2 as well, user2. Okay, so I have missed the comma here. Now let us run this code. So you can see both Ravi and Suraj are getting printed with their respective field values. But declaring a variable of a struct in this manner has disadvantages. Let us say in this first field I put value like surajyz.com, and then in the last field I provide the name. What happened here, if I print it again, this email suraj@xyz.com is appearing first, means it has been assigned to field name, right? So we can also print a single field as well. So let us try to do that. Here I will add a string user2 name, and we can access the name field from user2 using dot operator. So user2 dot name. Okay, if I run this code again, you will see user2 name is getting printed as suraj@xyz.com, which is basically the email. Why it happened? Because when we create a variable of type struct in this manner and we don't provide the fields here, the order in which we give the values will get assigned to all these variables. Okay, so this is one advantage. Let me fix this. So Suraj I will keep here, and then suraj@xyz.com in the email. Okay, it has one more disadvantage. Let us discuss that. Let us add one more variable here, is married. Okay, and this time it will be of type boolean. Okay, if you see this, we are getting a compilation error here. Too few values in a struct literal of type user. So user expects 4 things, but we are providing only 3. So we will need to pass the value for this is married as well. So let us say we pass true here. Okay, and for the first way of creating this user1 variable, we can still set the is married field outside this user1 creation. So we can do it like this: user1 dot is married is equal to false. Okay, so if I print the values again, go run structs.go. So here is the output as expected. Because of the disadvantages we just discussed now, we generally prefer the first way of declaring a struct variable. Okay, so let me comment out this user2 and its print statements as well. Now let me tell you one important thing. Let us say I remove this statement on line number 27. Okay, and now I try to run this code. Go run structs.go. So here you will see, although we have provided the value for only 3 fields, the value for the 4th field is also coming as false. Why? Because whenever you initialize a struct partially, all the remaining fields will take their corresponding 0 values. So here we have given values for name, age and email, but not for is married, and is married is a boolean and boolean 0 value is false. So that's why we get a false here. What if I only provide name? What will happen? So let us run this code again. Go run structs.go. So here you will see Ravi has come as expected. Then we have age, so 0 for age. Then we see some space in between which corresponds to the 0 value of email. So email is of type string and 0 value of type string is empty string. That's why you see some extra space here. And finally the 0 value for is married, which is false in this case. Okay, now let me uncomment this. Let us discuss the next concept related to a struct, which is nested struct. Let us say I add one more struct here, type address struct. And in this address struct, I want, let us say, two things. First is city, which will be a string, and then the state will be a string again. And now what I will do, I will add this address struct to this user struct. Okay, so we can do it like this: address, then again the name of the struct. Okay, let us not change anything here and print this code. So clear, go run structs.go. Now if you check the output, this part is same as before, but at last we see an empty structure here. Okay, so let us add here the address as well. So user1 dot address, this is corresponding to struct address. And then we can give the values for city. Let us say we give the value as Banaras, and then state we give as UP. Now if I save this code, clear it and run it again, you can see now it is printing the nested struct here as well with the values Banaras and UP. We can also change, if you want, this city or state inside this address. Okay, how we can do that? We can do it like this: user1 dot address, and then what do we want to change? Let us say we want to change the city. City is equal to Lucknow. Okay, and we'll print this user again. So this time you see, this time it is printing Lucknow here, right? So this is nested struct where we have used this address struct inside this user struct. Now let me tell you one important thing about a struct. Let me comment all this code and I will introduce a new struct. Let us call this struct name as MLA. Okay, and I will have the fields as name of the MLA, party of the MLA, and one more field has criminal cases as boolean. Okay, and I will introduce a function here, function change party, which will take this MLA as input parameter, and one more input parameter will be new party. This will again be of type string, and here we will change the party of the MLA. So how we can do that? MLA dot party is equal to new party. Now let us create a variable of type MLA. So MLA1 equal to MLA, then we need to provide the values of the field. Let us say Trump has become an MLA and his party is tariff party, and he does not have any criminal cases. Now let us try to print this first. Print ln mla1. Okay, so we'll print mla1 here. Now let us call this function change party. Change party, it expects MLA, and let us say the new party is war party, as Trump likes wars. And then let us print mla1 party. Okay, so here we'll do mla1 dot party. Let me clear this and run this code again. So here you will see mla1 initially, here is the Trump, party is tariff party, and has criminal cases is false. On line number 45 we call this function change party, which is supposed to have changed the party of this MLA Trump, but here we can see the MLA1 party is same as before, which is tariff party. So what has happened? What is the reason even this change party function was not able to update the party of this MLA? The reason is structs are value type. When we call this function like change party, what happens is a copy of the MLA1 will be created and that will be passed to this function change party. So any modification which we are doing here, that will be applied on the copy but not on the original MLA1 which we want to pass in this main function. So how we can change the party of this MLA? We need to pass this MLA as a pointer instead of a value. Okay, so here it is giving compilation error because now as this change party expects a pointer, we need to pass the address. So what happens now? Instead of a copy, the address of this MLA will get passed here in the change party, and whatever modification will be done in this change party function will be applied to this MLA. So if I run this code again, you can see now the MLA1 initially was Trump tariff party and hash criminal cases was false, but now his party has changed to war party. So this is it for this video. See you in the next one.